My name is Phillip Cromm. Like Jan, I don't have any slides prepared, so I'm just going to tell you a little bit about my CV, and then I'm happy to take any questions you have. So I grew up a little bit north of Frankfurt. When I'm old enough that I still had to do either go to the army or do some civil service instead. So I was becoming a paramedic. And did that for 9 months after high school, and then I started studying chemistry in Munich. I was not sure to go either for biochemistry or chemistry, but in the end I thought with chemistry it's maybe a broader foundation, and I picked chemistry in the end. But I was always from the beginning interested in biochemistry and then chemical biology later on. I did my bachelor thesis already with Horst Kessler in Munich, doing some peptide chemistry, focusing on integrin ligands, and then with his help I was able to move to Brisbane to do my master's thesis on melanocortin receptor peptides and cyclotides with Horst Kessler then and David Craig in Brisbane for 8 months, which was a really great experience to go abroad and spend some time in a different lab that early in my career. When I came back to Germany afterwards, I joined the Max Planck Institute for Molecular Physiology in Dortmund and the group of Herbert Waldmann to do my PhD. Focusing on chemical biology, again some peptide chemistry where we were doing staple peptides. So the idea was that we take secondary structures from certain proteins, we stabilize them chemically, so that they have a predefined shape, and with this we are able then to inhibit protein-protein interactions. And after my PhD, I moved on to do a postdoc with Craig Cruz at Yale University in the US for 2 years, and that's when I first got exposed and interested in targeted protein degradation. I'm not sure if you're familiar with the field, but I think it came up about 2015, where it was first proven that you can not only inhibit a protein, but you can actually chemically induce its degradation. So what you can do, you really highlight a protein in the cell as basically waste. Then the cellular degradation machinery picks it up and decides it's not longer needed. You can degrade it, and thereby have a different tool in your toolbox and different methods to really tackle certain diseases. After spending 2 years in the US, I came back to Germany and joined medicinal chemistry department in Berlin at Bayer in 2018. And from the early days, I was involved in our internal targeted protein degradation platform, and that was a time where we started looking into that, where we are setting up the first platforms, the first projects. So I was involved at that from the very beginning, and have been ever since working on different projects in the field of PROTACs and targeted protein degradation, where we're currently running a couple of projects in different disease areas to come up with clinical candidates and hopefully in the end with a marketed drug. So my background, I guess, is always a strong focus on chemistry, obviously, but I've always been bridging out a bit to biology, especially during my postdoc. I've been evaluating the compounds I made usually myself, so I have some tissue culture experience, Western blotting, and so on. So I have a basic understanding of biology. The PhD at the Max Planck Institute with Herbert Waldmann was very interdisciplinary as well. So here's one of the few people in Germany doing chemical biology with a very large group with a very large focus on chemistry and biology as well. So I got exposed to not only chemistry but to biology during my whole career, and I think this has benefited me personally quite a bit in my current job as well.